Good afternoon, and thank you very much for joining us today for the Ryerson University Center for Urban Energy Leading the Charge Conference, the next 10 years. On this panel today, we're talking hydrogen, the practical steps we need to take and technological leaps we need to make to fulfill Canada's net zero climate change commitments and to build back better from COVID. So welcome. Please post your questions in the Q&A, which is on the right hand of your screen, and we encourage audience participation and questions. We've got a great panel for you today. We've got Heather Kleb, Director of Next Generation Nuclear Technologies from Bruce Power, Doug Dumouriez, the VP of Business Development and Strategy at Next Hydrogen Corp, Brian Suku, the Director of Business Development at Hydrogenics, and myself, David Zekveld, Director of Hydrogen Business Development for Atura Power, a subsidiary of OPG. So I'll be moderating today, filling in for Robert Stasko, who unfortunately cannot attend today. And I'll be adding some commentary in some of our perspectives from Atura Power and OPG as the rest of the panelists provide their thoughts on hydrogen in Ontario and Canada. So let's just set the stage for today's discussion. Hydrogen is particularly well suited for the theme of this conference, the next 10 years. In Canada, NRCan released its hydrogen strategy in December of 2020, which states the opportunity for hydrogen by 2030, so 10 years from now, could be 4 million tons of hydrogen produced, up to 45 million tons of CO2 abated. And now I'm used to speaking in megawatts. I come from the electricity sector. Approximately equivalent generation capacity needed to make that via electrolyzer is 40 gigawatts. 40 gigawatts is the capacity of Ontario's electricity system today. So we're talking huge numbers and huge potential. To that end, NRCan has recently announced a $1.5 billion clean fuel fund to build capacity in hydrogen production in Canada. South of the border 2 days ago, the first US DOE energy Earthshot was made. That Earthshot is made to have clean hydrogen at $1 a kilogram within this decade, so within the next 10 years. So there's a lot happening in hydrogen globally, in North America, and here in Canada. So I'd like to invite Heather Kleb, first up on our panel today, to tell us a bit about yourself, about Bruce Power, and what are your thoughts on hydrogen over the next 10 years, and where do you see hydrogen, particularly nuclear, playing a role in the production of hydrogen? Over to you, Heather.
Thanks, David. Good afternoon. I'm pleased to have the opportunity to participate in this panel. As mentioned, my name's Heather Kleb, and I'm the Director of Next Generation Nuclear Technology at Bruce Power. I'm an ecologist by training and have spent many years assessing the environmental effects of various industries, including nuclear. But in recent years, I've transitioned to the licensing of nuclear facilities, including radioactive waste management and nuclear power generating facilities. In my current role, however, I focus on Bruce Power's energy innovation interests, which is actually appropriate since many innovations tend to get caught up in policy and regulatory space. Now, Bruce Power fulfills its energy innovation interests through the Bruce Power Center for Next Generation Nuclear, which was jointly established with Cameco Corporation late last year. The center, which is situated within the Ontario Nuclear Innovation Institute, allows Bruce Power to explore energy innovations through a series of partnerships. And through the center, we've actually already established partnerships in the areas of small modular reactors, hydrogen, and fusion energy innovation. And we've also supported the innovations that have originated within our existing CANDU fleet. But together, we develop communications materials, conduct feasibility studies, and prepare policy papers to support the advancement of these innovations. Now, I'm carrying out this work from my home on Lake Huron right now. And so I'd like to start off this discussion with an acknowledgement. I'd like to acknowledge the traditional and treaty territory of the Anishinaabe people of the Saugeen Ojibwe Nation, including the Chippewas of Nawash, Neashinigami, the Chippewas of Saugeen First Nation. So thank you. And thank you for the opportunity to share Bruce Power's perspective on how hydrogen can fuel the future. I think some people would say that Canada is, many years behind Europe, Asia, and the US, but we foresee opportunities to advance Canada's hydrogen economy locally and within the next few years. And we believe that nuclear is a natural partner in the advancement of Canada's hydrogen economy because nuclear provides the reliable, non-emitting supply of electricity that is required to produce hydrogen without carbon emissions. We're also hydrogen consumers and are therefore very familiar with its use and handling. Now, before I jump into Bruce Power's hydrogen production opportunities, I wanted to mention that we're also very supportive of the Bruce Innovates Foundational Hydrogen Infrastructure Project. And that is a project, a local project, a Bruce County initiative to assess the technical, financial, and socioeconomic considerations associated with hydrogen production, storage, and use in Bruce County. So the goal of that initiative is actually to establish the county as a leader in developing the hydrogen economy, whereas our initiative is more focused on that initial first step towards a local hydrogen demonstration project. Now, in terms of how hydrogen can fuel the future, we foresee opportunities in three main areas: cogeneration with existing and next generation nuclear, hydrogen displacement of natural gas and diesel generation, and hydrogen storage and handling for current and future uses. So with respect to cogeneration, there's the potential for hydrogen to be made by via electrolysis using less expensive off-peak electricity from the existing CANDU fleet. But looking ahead to the future, we also foresee the potential for small modular reactors to support more distributed hydrogen production, including in Canada's north. So as I mentioned, late last year, Bruce Power entered a partnership or agreement with Westinghouse Canada to support them as they work to develop and deploy the eVinci microreactor across Canada. So the eVinci is an especially portable microreactor. It has 5 megawatts of capacity. And just to give you a sense of how small that is, our reactors are operating at about 800 megawatts each right now, except the one that's in major component replacement right now. But so 800 megawatts, this is 5 megawatts. So very small microreactors, also known as nuclear batteries. So these microreactors are especially portable, and they're being targeted for off-grid applications, such as at mines and in remote communities that would typically rely on diesel. Now, the interesting thing about the eVinci microreactor is that it produces both electricity and heat. And the output temperature of that heat is on the order of 600 to 700 degrees Celsius. So not only does it have the potential to produce hydrogen from a non-emitting source, it also has the potential to make hydrogen production portable. So now in terms of the displacement opportunities, because nuclear is non-emitting, it also has the capacity to displace greenhouse gases from other sectors. So for example, through the blending of hydrogen with natural gas, nuclear has the potential to displace GHGs without very significant changes to the natural gas infrastructure. Hydrogen can be, we already know, hydrogen can be injected into local natural gas pipelines, and that's for mixing and fuel displacement, which can then be used for heating and other industrial purposes. The potential for hydrogen blending in natural gas lines also has the potential to optimize that low-cost production because it allows hydrogen to be produced during times of low electricity prices. So not surprisingly, local petrochemical, chemical manufacturing, and other sectors are interested in the opportunity to displace natural gas with hydrogen from nuclear. And we've already developed some partnerships in these areas. And finally, as mentioned, the nuclear industry already has experience with the storage and handling of hydrogen. Hydrogen, which is stored on site, is fed to our turbine generators for
used to control oxygen levels in certain systems to prevent corrosion.
But first, the hydrogen is cooled and dried and then fed to the generator via a pressure regulating valve to maintain a certain pressure. We also carefully maintain the hydrogen purity at over 95% to prevent fire and other risks. And you don't need to know any of this, but all of this is to say that we're already familiar with the storage and handling requirements of hydrogen from a temperature, pressure, purity, etc. perspective. And so while there may be other opportunities for hydrogen storage, and locally they've talked about salt caverns and other geological formations, this first step in establishing a demonstration project will likely rely on these more conventional hydrogen storage and handling techniques. So to sum up, we believe that hydrogen is a key enabler in reaching net zero by 2050, but it can't go it alone. We believe that hydrogen production will require integration with nuclear and other sectors and energy innovations in order to be able to fully realize its potential. Hydrogen will require, the right resources with respect to the source of non-emitting electricity, an economical cost of power, but also the right partnerships. And there are opportunities to partner with other sectors, such as chemical manufacturing and the natural gas sectors, which are actively working to reduce their GHG footprints as well. And there are also opportunities to partner with and advance other energy innovations, such as small modular reactors. And in the case of small modular reactors like the portable Davinci microreactor, there's also the potential to support distributed hydrogen production, to Canada's north. So finally, I'll say that Bruce Power is a willing partner, both when it comes to producing non-emitting hydrogen and supporting other sectors and technologies, as we all race towards net zero by 2050. And with that, I'll say thank you, and I'd be happy to answer any questions you may have.
Great, thank you very much, Heather. And I haven't seen any questions come in yet, but I do encourage the audience, if anything that we're hearing does raise some interest or some questions, please do put them in the Q&A, right-hand side of your screen under Q&A. But thanks, Heather. Great to hear what Bruce Power is doing in nuclear and leveraging nuclear for clean hydrogen production and the opportunities to use the new SMR technologies as well for hydrogen production. That's great to hear. So next up, we've got Doug Dimmering from Next Hydrogen Corp. Doug, thanks very much for joining us today. Can you tell us a bit about yourself, about Next Hydrogen, and where do you see the hydrogen world going in the next 10 years?
Good afternoon. Thank you for having me. It's my pleasure to participate. I'm working in the business development with Next Hydrogen, and prior to joining Next Hydrogen, I spent a lot of my career working in the wind energy and solar energy business, developing wind projects in Ontario and also primarily in the United States. And so I have been around renewable energy and emissions-free energy for my career. Next Hydrogen has been in business since 2008, and it's been developing a new innovative technology, new innovative electrolyzer that has been designed from the beginning to integrate well with variable resources, particularly with wind energy, which can ramp up and down very quickly. And our technology has been designed to utilize that energy and ramp up and down quickly with the traditional alkaline electrolysis reliability. The electrolysis industry, we've set out some very aggressive goals as a group to reduce our capital costs and to increase our efficiencies, and those are laid out in a number of documents you could find around. If we're successful, and I believe we will be, you'll see the cost of electrolytic hydrogen dramatically over the next 10 years. So the cost to convert low-cost electricity when it's available into hydrogen will significantly reduce from the current level, and we believe it'll become competitive with regular hydrogen when you consider the cost of regular hydrogen, with natural gas derived hydrogen when you consider the cost of the carbon in the long term. And where is thinking about the Ontario market in particular, right now our electricity system has significant surpluses of clean emissions-free electricity, which when it's available, it's frequently exported to our neighbors at very low costs. And we could, in the near term, utilize that low-cost electricity to, rather than export it at those very low prices, we could utilize it within Ontario to create electrolytic hydrogen, green hydrogen, to start to transition our Ontario economy. The future of hydrogen in Ontario, though, will depend on leadership, right? Because one of the anthems you often hear when talking about the energy transition is to electrify everything. And so an example of that is the growth of electric cars. So that will increase the load on our system and the requirement for energy. And as that system grows, in order to really be effective, we need to increase the supply of clean and renewable energy on our grid in order to supply that increase in load. We can't transition our economy if we're not increasing the amount of clean generation in our electric system. And so that will, in the future, if we follow that path to grow our electric system while still maintaining or even reducing its emissions footprint, that will mean that we'll have even more variability in our electric system, and the opportunities to use hydrogen production to utilize periods when there is excess electricity to produce hydrogen that can then be used in other sectors of our economy to reduce their emissions in areas where it may be more difficult to abate their emissions. So, for instance, if you take the case of heavy transport, if you take that hydrogen and the easiest thing to do with it is just to inject it back into a gas line, and as long as we're keeping the mixtures at the safe level, or if we've made adjustments to even go to higher levels in our system, that would be a fine use. But you can get 3 times the emissions reductions from the same amount of hydrogen if you use it for heavy transport. And Ontario hosts the 401, which is one of the heaviest used heavy truck corridors in North America. And if we could, for instance, have 1,000 megawatts of electrolysis operating at 55% capacity factor. So it's not running all the time. It's not running when there's the peak electric demand. That would power about 5,000 trucks and reduce emissions in our trucking industry by about 1 million tons per annum. That's a significant reduction that can be enabled in our economy. So that's an example of what you can do. We could also utilize electrolytic hydrogen as industrial feedstocks, which is still would reduce emissions not quite as much as that heavy transport example, but about double what you would get by just replacing natural gas. And so that's another use. But in short, I think there's a lot that hydrogen can do. It's not a miracle pill that's going to solve the emissions problem, but I think in concert with a growing electric system that has an increased amount of renewables in it, hydrogen is a key tool to number one, absorb that energy when we have more energy than we need, and then make it available in other sectors where electricity is not a replacement for their current feedstocks, like ammonia production, heavy transport fuels, that kind of thing. So that's my perspective. Thank you.
Great, thank you very much, Doug. So it sounds like that new electrolyzer technology for integration variable energy resources is well suited to what we could see in the province as electrification continues to increase demand. In your concept of helping to have hydrogen support decarbonizing heavy transit on Highway 401 is one that we're looking at closely as well. So thank you very much for your insights. And now I'll turn it over to Ryan Suku, Director of Business Development at Hydrogenics. Hydrogenics is a longstanding company in the hydrogen world from Mississauga and recently acquired by Cummins. But over to you, Ryan, to hear what the next 10 years looks like for you.
Great, and I want to thank everyone for the opportunity in creating this forum for us to share what Cummins is doing and investing in hydrogen. I mean, it's been an exciting few years for sure, especially with the direct relation of Cummins acquiring Hydrogenics, and that's really a reflection of the growth we're seeing in the market driven by hydrogen. And we're unique in the sense that we produce both electrolyzers and fuel cells. So we're feeling that energy shift, the momentum in various applications globally coming from electrolysis and fuel cells. And within Cummins, that's generally what we're feeling. This growing need for electrification, decarbonizing our fuel, and really has ignited our view on how do we present ourselves to be capable to support that shift. And in doing so, we created a new division called New Power. So within Cummins, you have the traditional engine, power system components, and distribution business. But now we also report on a new group called New Power. And inside of New Power is all of that investment Cummins is making towards hydrogen and in general the electrification market. We have acquired GE solid oxide fuel cells and a number of battery companies also. So we do believe that hydrogen is going to play a key role as we move forward, but we're also supporting a number of other technologies because we understand that shift is going to be regional and different partners of ours are going to have different requirements that require those technology. The primary focus of the hydrogen group really is around the fuel cell and the electrolyzers. And as you heard earlier today, there's tremendous amount of potential for hydrogen within Canada and globally. A large part of our growth that we see coming from fuel cells are actually in the medium and heavy duty sector. You would have seen a bunch of nice pictures, I'm sure, if you Google fuel cell trains of the Alstom fuel cell train that's running in Germany. That's one of our collaboration. We're showcasing how the technology using hydrogen through a fuel cell. And in general, a fuel cell is just taking that hydrogen and converting it to electricity, right? So it's almost like a power supply. So when you think of the potential for fuel cells, you really got to draw on where can this technology be used? And it's really everywhere an electric motor is currently being used, right? That's the potential for a fuel cell, to power anything that requires electricity. And we see that growth happening, and we believe mobility applications like the trains, which are really, that initial step into heavy duty application, are going to grow. And the way we think about moving people and goods are really shifting. And there's an emphasis now on trying to meet, targets such as 2030 and 2050 emissions requirements. That is also accelerating that need to look at how we're doing things and are we using the right technologies to do so, not only in the midterm, but in the long term. And then we have the electrolyzers, right? We're so proud of what we've done with electrolysis, especially here in Canada. I mean, our technology, we have both alkaline and PEM electrolysis, but we have been developing, if you will, the PEM electrolysis more for the megawatt scale application. And a great showcase of that is what we did with Air Liquide in Quebec, which is basically a 20 megawatt facility producing over 8,000 kilograms a day of hydrogen. That hydrogen is essentially being produced with an industrial partner of ours, Air Liquide, and it's not trying to be subsidized, or it's not trying to showcase as a project. What's really, really interesting about that is exactly what Doug said, right? The commercialization of this technology is happening. And that decision was really, drawn by Air Liquide having to consider purchasing a new steam methane reformer or an electrolyzer to do their business, which is basically producing hydrogen and distributing that to customers. So when you look at, when a company is willing to transition into a commercial engagement like that and use the technology, we're very excited about it. And that just kind of keeps building on the momentum we're seeing globally. When you look at how we look at the market is moving for the use of hydrogen, and I'm going to zero back into fuel cells. We have trains that are running, and we're going to do a lot more with trains. We see that avenue continue to grow. Right now, it's commercial application where it's moving people, but there's a huge potential in the goods movement and the industrial side of the rail network that's also being looked at. The Cummins traditional market, as you know, has been medium and heavy duty application for trucks and buses and mining, right? So all of our 13 divisions, if you will, where we produce anything from a mining truck to an RV vehicle or a diesel genset, are really asking, what can I do with hydrogen? I'm hearing about it. How are we going to, when are we going to get access to this technology? And it's almost like holding back the floodgate of enthusiasms, and we have to pace ourselves. We have to make sure we're releasing the technology for a market that's right. So we are transitioning in various applications from semi trucks to buses. We're even in Europe, we're doing refuge trucks. So it's not one silver bullet. What we're seeing globally is the adoption and the use of fuel cell, powered by hydrogen, of course. It is really dependent on that geographical requirement. We're also very pleased about the growth we're seeing in Quebec relating to refueling stations, right? We recently collaborated in building the first public refueling station there. So we're hoping that momentum grows, because it's not just about how we're servicing the commercial fleet, but the everyday person, right? We want to get this technology accessible and have those fuel cell cars have the ability to get hydrogen. And then, we look at this as, how do we maximize our collaboration and enablement in this space? I mean, traditionally, Cummins does not just build one single block of an engine, if you will. We supply a slew of products, right? That makes up a component list. So we're almost like a packaging of a powertrain when it comes to engines that we put out there. So our partners have the ability to work with us to determine, do they want just the fuel cells? Are they looking for more expertise, as we traditionally do in packagings and controls and drivetrain? And it is changing, right? And what we're happy to say is, a lot of the core partners of ours that do things traditionally with conventional technologies are looking deeply at this. But we're not only not waiting, right? That's the drawback of all this. If we were to sit back and just wait, we would essentially delay the progress. And what we've done recently is we've also invested in a joint venture with a hydrogen tank company called Enprox in Europe. And that's one of our initiatives where we're really trying to address the total cost of ownership, right? We know fuel cell vehicles make sense. By applications, there's great value for not only on zero emissions, but on productivities for those customers. And what we're trying to do is figure out, how are we going to continue to bring down the total cost of ownership of those systems? And it's through collaboration, right? We acquired Hydrogenics for the fuel cell electrolyzer technology, but now we're partnering in the industry with Enprox, for example, to address, how do we get the right tanks for the applications we're looking at, and also tracking the right price point that enables this technology to continue to succeed. Hydrogen generation is also a big enablement. Infrastructure in general has been the holdback, right, to the industry. How do we move further in stationary applications with fuel cells or even vehicles? It's always going to come down to, how do we supply the fuel, which is hydrogen, at a reasonable price, right? And that is question one. How do we get that down? How do we enable that market? And then I think what's increasingly happening is this growing need for looking at the decarbonization of the fuel, right? Hydrogen can be made from various methods, and they may make sense depending on where you are. But we do see an increasing growth potential for green hydrogen. And that's why the collaboration with Air Liquide on a 20 megawatt facility is instrumental, because that facility, if the electricity that feeds that electrolyzer comes from a renewable source, that hydrogen is actually renewable. It's actually green. So it allows that business of Air Liquide to actually have the ability on the dime to switch over and say, I'm now going to sell green hydrogen into the market. That hydrogen produced is going to everyday customers of theirs, but it's already building. They're putting in the infrastructure, and that has to continue. The distribution of hydrogen, the generation of hydrogen, we do have to continue that activity, because I think that's very, very key for not only using hydrogen to its potential, but as energy storage, as we heard about injecting the natural gas pipeline, but also as using it to enable fuel cells. We are global, and our initiatives that I just mentioned are essentially boundless, right? We have a huge amount of potential happening in Asia, in China in particular, with fuel cells. In Europe, we recently announced a gigawatt factory, right? We plan to build a gigawatt factory for electrolysis in Spain, and we announced that a few days ago because of the green hydrogen growth we see. So in Spain, we're going to build a electrolyzer factory using our core PEM technology for a multi-megawatt system that is supposed to be operational by 2023 at an initial capacity of, say, 500 megawatts production, and scale easily to a gigawatt. So that is an example of how we're going to continue to support the market, and that facility is actually producing green hydrogen through its mechanism. So keeping that in mind, we're really trying to figure out where is the best places to put the energy, but we are very focused on hydrogen. Every electric vehicle is largely every fuel cell vehicle is largely an electric vehicle, right? 90% of a electric vehicle has everything that a fuel cell vehicle needs. So the transition to a fuel cell market is natural. The fuel cell is just another form of battery, and we're looking to continue to grow that as we progress. There are different parts of the world is going to be driven by factors such as political, public, drivers. But at the end of the day, we do believe hydrogen is going to play a key role in enabling change. And that's what's exciting. How do we continue to support that? Through the use of fuel cells and electrolyzers. Our expertise in electrolysis, goes back, I want to say, about 75 years plus. Through the acquisition of various companies like Stewart Energy, we have been doing this a long time. And it's not to say that we're only producing electrolyzers for, green hydrogen. We have a healthy collaboration in the industrial sector in putting our electrolyzers in various applications, from producing glass, even making butter. There's a big market for hydrogen. And I think if we can continue to bring the cost down and utilize all the options available, that industrial sector would gladly use a decarbonized hydrogen molecule. But we have to make sure that we are at the price point that makes sense for those business, and work towards it rather than say, it's too far out. And that's what the interest in ours is, as we collaborate not only with industry players, but with the end users, to understand how do we need to adjust, where does it make sense, because absolutely we believe renewable hydrogen is a great value, and we should not negate the potential also of the industrial sector for using that hydrogen, even though it may not traditionally go to, say, something as energy storage or a fuel cell. I think the key for us is just how do we continue to decarbonize by making our technology available to everyone. And I'll just close with, we're very committed, as you can tell, towards the hydrogen market, but we understand that different region will move at a different pace. And exactly a good example of that is Canada. I mean, I'm located in our Mississauga office. Hydrogenics was HQ in Canada here, and we would love to get more hydrogen activity and engagement going, because we think Canada has tremendous potential. As you heard from the previous speaker, the electrolyzer really doesn't pay attention to if the electricity is coming from a solar or a nuclear power plant. At the end of the day, for us, it's the same device, but we want to work with those partners to see how do we help invest in building out that infrastructure and collaborate in the usage of either electrolysis and fuel cells. Thank you.
Great. Thank you very much, Ryan. Very exciting things happening at Cummins in the new power division. Great to hear what's going on with fuel cell technology and where you see that going. in the facility that you have operating in Quebec with Air Liquide, world class and one of the largest operating to date. So exciting times. I think you said there's a lot of eagerness in the market. I can tell you that's the case. We'd love to see more of those Cummins powertrains out for heavy duty vehicles. So I'm going to share a little bit about Atura Power and Ontario Power Generation's goals. I think it doves nicely with what Ryan just shared about, looking for infrastructure in Ontario. And before I do so, just a reminder to everyone who is in the session, please add your questions to the Q&A on the right-hand side. I see we've got 4 questions, and we'll get to them right after my short chat, but please do add some more. So Atura Power is a wholly owned subsidiary of OPG, and it owns the hydrogen business. And to give some context about who OPG is, we're the largest electricity generator in the province of Ontario, with a clean energy base of 66 hydro facilities, 1 large solar, 2 nuclear stations. We've got peaking capacity through 4 natural gas stations. And we see an opportunity to leverage this infrastructure for producing hydrogen across the province. As was stated, Highway 401 is one of the busiest corridors in North America. And when we see those Cummins powertrains and the heavy duty trucks, we want to be ready to be able to support with low carbon hydrogen along the Highway 401, or the hydrogen highway as some are starting to call it. We do see a future that involves small modular reactors as well. At our Darlington location, we're looking at a grid scale application of nuclear technology, SMR technology, and then GFP, another subsidiary who's looking at off-grid applications. And OPG has a history of significant climate change initiatives. In 2013, we shut down 9,000 megawatts of coal. That was one of the largest climate change actions taken to date at home here in Ontario. And looking forward, we've made a net zero commitment for 2040 and to be a catalyst for a net zero economy in Ontario by 2050. And we agree electrification has a big part to play in that, but hydrogen is also an essential to meeting those net zero commitments. So we're looking at how we can leverage our real estate, our electricity infrastructure, our energy market knowledge, our participation in the electricity market to make electrolyzer produced hydrogen happen and happen efficiently and effectively. Part of the cost equation, a big part of the cost equation is the cost of electricity. So where we can help and leverage different market mechanisms, we're looking at every opportunity as the electrolyzer vendors are bringing down the cost of the electrolyzers. So specifically, Atura Power released a press release about 2 months ago asking for requests for information from the electrolyzer community for 20 to 200 megawatt size electrolyzers, which gives you an idea as to the scale of production that we're looking at. We do see distributed production being an asset around the province in areas where it's needed to reduce some of that infrastructure requirements. And so we've recently made an announcement about several feasibility studies that we're doing for different sites that'll, we think, be great candidates for hydrogen hubs in the province. So working with partners on the call today and with others in the hydrogen economy, we definitely see an opportunity for several hubs in Ontario and look forward to playing a role. So I'll pause there and take a look at our Q&A. It looks like we've got several questions. So first off, we've got a question from Paul Stevens, and the question is, how soon do you expect to have new hydrogen refueling stations operational in Ontario? Maybe I'll start with Ryan on that one. I know you've talked a bit about infrastructure and being located in Mississauga. Perhaps you've got some insights on timelines.
I think it's really coming down to demand. It's not a question of technology for sure, right? Or the how, right? It's we're waiting for the demand, and I'll just kind of tiptoe a little bit. The reason we built a station in collaboration in Quebec was the car OEMs agreed to release there, right? So that Point one is, can you generate demand to utilize hydrogen? And when you say infrastructure, I'm assuming you mean hydrogen station. I mean, it'll be amazing if we can get hydrogen pipeline in, to help enable hydrogen use in buildings, if you will. But I think hydrogen pipeline's a little ways out. But in the cluster that we're currently located geographically, Ontario, there is actually a surplus of hydrogen because of our existing steel and other industrial need. Yes, it is not green hydrogen, but there is availability of hydrogen. So the question isn't about generation. It's probably going to come down to utilization. And if it is about targeting mobility application, hydrogen stations will be there if there is a demand by the vehicles. Another way, if we didn't do it with the passenger car demand, transit agencies, right? They're an amazing potential clients for fuel cell buses. Fleets, the Pearson corridor is one of the busiest for goods movements in North America. So when you look at all the Class 8 trucks and medium duty vehicles, Class 6, and vehicles that are operating, it's a huge potential. But the question then becomes is, well, why aren't those end customers or OEM transitioning, right? And that's what we're trying to help accelerate. If we can, it's not a lack of need potential. It is, can we generate the need, right? If those vehicles did have fuel cells in them, there would be a tremendous drive for that infrastructure. So I think it's trying to figure out how do we create the need. And then lastly, I mean, no business case should run on this, but government support helps. When you're trying to launch a technology shift like we are, so it's not saying fuel cells are new or hydrogen is new, but when you're building out infrastructure, it's really difficult to say to an end user, sure, go buy 10 trucks. Oh, but by the way, buy your own refueling station, right? That's a tough model for any business. So I think we have to accept that government, whether directly or indirectly, have been investing in the petroleum distribution of fuel, like gas station and network for a long time. And if we want to enable hydrogen as a potential fuel source, we're going to have to invest also in helping to build out that rollout, because it's not fair to the end user to have to pay for a hydrogen refueling station anytime they're thinking about shifting to fuel cells.
Yeah, great points. Thank you very much, Ryan. Doug, Heather, do you want to add anything on the question of infrastructure refueling stations in Ontario?
Just a couple points. I think when you're looking at where the next refueling stations are going to come, they're going to be probably, to Ryan's point, they'll be private, built by people that want to transition a fleet of vehicles that they might have that all return to the same point every day. And that way they only need the refueling station at their base. And that's probably where you're going to see the first refueling stations. If there is more support, maybe those fueling stations could be more publicly accessible if there's a program available to try to make that happen. But I think you're going to see it mostly supported by, in the near term, by fleets that all return to the same point every day, like buses or regional transportation fleets. The other example is, of course, lift trucks in warehouses where they have a refueling station, but that's just going to be inside their warehouse.
Great, thanks, Doug. And we've got a few questions on nuclear, so I'll turn to Heather on that. 2 questions for you, Heather. First one regarding the micro nuclear. What's the cost per kilowatt hour and what fuel is required? And then secondly, more generally on nuclear, nuclear waste disposal solution is needed. How do you see the storage question evolving in Ontario?
Okay, thanks, David. So starting with the first question, I mentioned that we carry out feasibility studies. We've just initiated a hydrogen feasibility study, but we've also, we're on the verge of completing a feasibility study regarding the deployment of the Davinci reactor in Canada. And we are directly comparing the Davinci with diesel generation, so those off-grid applications that I mentioned in the north. And I'm not going to do a big reveal today and share our numbers as we finish that study, but I will say that the microreactor can go head-to-head with diesel. So it's competitive. Second question, what type of fuel is required? So
So the Davinci uses a uranium-based fuel.
and people may be aware that Canada is the largest supplier of high-grade uranium in the world. In terms of the supply, it may not initially be sourced within Canada because we require certain fuel fabrication capabilities as well, but ultimately it will be a Canadian uranium based fuel. So just to address it briefly. Moving on to the second question regarding radioactive waste management. So I was formerly with Atomic Energy of Canada Limited. I worked in decommissioning and waste management, and also obviously working out of the Bruce Nuclear Power Plant, which is the largest operating nuclear power plant in the world. I'm also exposed to our practices there. And what I would say is that Canada really has a tremendous amount of expertise and knowledge in radioactive waste management, which people might not hear about because we're all quietly doing our jobs, but there is a tremendous amount of expertise here. There were two follow-on questions regarding storage and disposal. So we're already storing radioactive waste safely and effectively. It's already in a safe and stable condition. We undertake that work every day. In terms of disposal in the longer term, so we have storage plans that are, on the order of decades to even hundreds of years. But in the much longer term, it's in terms of oversight and administration, what they're looking at is the proposal for a deep geologic repository. And that is consistent with other proposals around the world that are being advanced. In terms of looking into the future and saying how that will evolve in Canada, but my expectation is that we'll follow best practice and we'll continue to provide those effective practices in radioactive waste management. And that's a very brief response to those large questions.
Thanks very much, Heather. And jumping on back to hydrogen here, one of the first questions we received actually is about the efficiency of hydrogen. So maybe I'll start with Doug if you want to take a crack at answering that, and then maybe Ryan if you want to add Cummins' perspective. So please elaborate on efficiency of hydrogen.
Currently, I would say that, like, if you're looking at the production side, it's 60 to 70% is typical efficiency of the production side, and then the efficiency of the consumption side depends on what you're using it for. But I could hand that over to Ryan to talk about the efficiency of fuel cells.
Yeah, it as Doug mentioned, it probably takes somewhere between 45 to 50 kilowatt hours to produce 1 kilogram of hydrogen. Electrolyzers work on basically breaking apart water. Water is H2O. So they use that electricity to separate the DI water, which is extremely pure water. So it's a fairly efficient process to generate hydrogen. But when you have to take the hydrogen and put it through back a fuel cell to regenerate electricity, you're about 50% efficient in that process. So when you combine, the energy loss from going from electricity to hydrogen and then from hydrogen back to a fuel cell, you're probably going to be in the mid-20s of net efficiency. So it isn't practical to say I'm going to store hydrogen in a day. I'm going to store electricity in the form of hydrogen in a day and then run it back through a fuel cell that night. There are other technologies like batteries that are going to do that much more efficient. So, where hydrogen would shine is when you have to store a bulk amount of energy. So where you would exceed the electrical storage capacity of traditional technology, hydrogen has huge potential there to basically convert electricity to to hydrogen and store it that way. Or if you have a long runtime requirement. So if you were, in a situation, in a backup power situation where you got to run for multiple days in generating electricity, it's not practical to use batteries to store multiple days of load. You would use, say, a fuel cell to act as a range extender, if you will.
Okay, thank you very much, Ryan. And we've got one additional question back on the infrastructure, which is related to transport. So are pilots for hydrogen use in transportation being considered in Ontario similar to hydrogen trucks where we see a pilot in Alberta? So maybe, Ryan, I'll start with you and others can add.
There's always interest. We're interested as a supplier for sure. What we're trying, what happens with what's happening in Alberta is it's basically like a consortium of partners that got to come together. So, the most important one that's missing is probably the end user, right? You need someone who's already doing this business, who is engaged in making this energy change to their, their overall organization. And it's not a straightforward process. So it has to be people who are committed, because it's a journey, literally, to bring fuel cell in, because hydrogen fuel cells are a disruptive technology, right? It's different than how they do things today. It's a whole other platform. It's not that you could take an existing vehicle and, economically retrofit it to be an electric platform for like a fuel cell. So you're also looking at a significant amount of engineering effort. So it's likely that end user, if you did find them, would have to procure like a new fleet or a new vehicle using an electric chassis, and then we'll add on the fuel cell. But we haven't had any deep conversation to do something similar, but we are interested in understanding who those partners would be locally. I would say there is not a lack of interest even within the US to do the same thing. So that's why we're being a little sensitive to ensure we have an engaged end user, because as Cummins, we're not interested in doing just a project. We're generally interested in making a change. So we would love to see that energy and excitement put into transitioning an organization to fuel cells, but they're going to continue with it, right? And that's really the key, is how do we build on it, rather than saying, I'm going to do a demonstration just to prove fuel cell works. No, that's really not needed today. We know that they work. It's now understanding how do we get those end users excited about the technology so that technology providers like ourselves can participate and just, understand the value chain here. The end users buy their trucks from OEMs and Cummins supply engines to the OEMs. So really, you have to get those three, anchors kind of all in a room and saying, this is what I want to do. And I'm sure it'll happen if that situation did arise.
Thanks very much, Ryan. And you're right. Pilots have been done. I think we've seen the technology. It's a question of really making that transition. It's a great response there. Anything to add, Doug and Heather?
No, I would just
to Ryan on that one.
Yeah. I would just say the 401 didn't become known as the hydrogen highway without anybody talking about that happening. But I'm not really up to date on real action.
Yeah, absolutely. Need to see the action behind that from a transition standpoint. We do have one other question here from Iris Yu. Does the production efficiency, and I believe that's what we're talking about in terms of the 60 to 70%, 45 to 50 kilowatt hour equals 1 kilogram of hydrogen, does that account for the energy used to distill the water? So maybe Doug and then Ryan.
Well, there's no distilling water required for the electrolysis, for alkaline electrolysis. I'm not sure what Iris is getting at, but yes, it would. The efficiency number we're quoting is the all-in, at least that I was quoting is the all-in. So it includes all the ancillary loads and just looks at the whole system, including purification and drying of the hydrogen.
So, I mean, our alkaline and PEM electrolyzer technology for us runs on DI water, and the source of that water comes from the tap, right? So it's your local tap water that basically goes in, and we have a water treatment plant. So yes, that efficiency I gave, I believe, was at a system level. I am happy to be proven wrong about the 45 to 50 if some of my engineers are on here, but yeah, and just to add light to the water element, you know, when you look at what's truly in your tap water, only about 50% of what comes into the unit gets converted to DI water. So there's almost a 50% rejection rate because of all of the minerals and organic matter that's already in our tap water. So, but from our electrolyzer, yes, we run on DI water, but the source of that DI water can come from a well, can come from your tap, but it has to be processed.
Great, thanks so much. One question from Mark Winfield to Heather, just what's the status of the Davinci reactor?
Yeah, so they're wondering if there was a prototype, so not at the current 5 megawatt scale, but they're currently testing components of the design in preparation for a demonstration project that's targeted for 2026. So that's the current status. So it's not too far into the future.
Great, thanks, Heather. And so we've gotten through all of our audience questions here. I'm going to open it up for closing remarks from each of our panelists today. Let's start with Heather. Any closing remarks?
No, I'm just very pleased to have the opportunity to participate in this panel, and it's really interesting hearing from the different perspectives and also the involvement of different sectors and non-emitting power sources. So I really enjoyed it and appreciate it. So thank you.
Just to reiterate a little bit, the hydrogen sector benefits from having a clean grid. It's probably no coincidence that Ryan's big project is in Quebec, where the grid is clean and reasonably priced. So having a clean grid allows people to utilize electricity and not and decrease their emissions profile. So let's electrify more things and use hydrogen to electrify effectively other difficult to abate sectors.
Again, Ryan?
Bring on the enthusiasm. We want it. I have hydrogen in my veins, so I will tell you everything is possible, but I would only say it is not a sprint, right? It is not how quickly can you get the technology in place. It is more like a jog, right? Because we want to last a long time. We want to get to the end game. Cummins' view is we believe that fuel cells will reach parity with diesel, and that is not hard for us to say as a diesel company. All right, so we make all sorts of engines, but we do believe it will reach parity. We need volume, and we agree with like the projections from the U.S. Department of Energy of like 5,000 units per year of fuel cell produced. We'll target somewhere around $120 per kilowatt. Right, it's the pricing for a fuel cell. Now on the infrastructure side, I'm going to tell you that is rapidly advancing. And I wouldn't be here telling you that we're building a gigawatt factory for electrolysis in Spain that's operational by 2023 if there wasn't a need, right? We don't make those large investments if there wasn't growth. So again, it is not a sprint. It is a jog. And we do believe that we will get to that point if we continue to invest in it, but partner strategically to do so.
Thanks very much, Ryan. And I guess from our perspective, Doug, you mentioned that the Quebec electricity market is good and clean, largely hydro-based. I'd echo that Ontario also has a very clean electricity grid based primarily on nuclear with a good amount of hydro and a significant amount of renewables on the grid as well. So we do think that low carbon hydrogen, green hydrogen, very much potential in Ontario, and we think that Atura Power and Ontario Power Generation have a role to play in helping to make that happen as well. So we thank you very much for joining us today. I think the session has ended, and appreciate the inputs of our panelists today. Thank you.
Have a good day.
Thank you. Bye.
Thank you. Bye.